Welcome to the Washington Stormwater Center's video on tracing sources of invisible pollutants in stormwater runoff. This video will provide you with ideas on how you can successfully trace the sources of the pollutants regulated by the Industrial Stormwater General Permit that are often difficult to find and control, specifically zinc and copper. You should be aware of where these pollutants can be found at your facility so you can prevent them from getting into your stormwater. Identifying and removing these sources of pollution will save you from having to treat your stormwater, which can be quite costly. Let's start with zinc. This metal is found in many industrial equipment and materials. Anything that is galvanized is coated with a layer of zinc for corrosion prevention. Some common sources of galvanized materials include roofs, downspouts, and chain link fences. But don't forget about HVAC systems, slip-resistant metal ramps and scaffolding, barbed wire, and galvanized steel siding on buildings. And there are other sources of zinc that should not be overlooked, such as tires and tire dust, motor oil, wood preservatives, some paints, hydraulic fluid, zinc carbon dry cell batteries, moss killer, and even galvanized farm tubs used as decorative planters. Remember, the benchmark for zinc in Washington state is 117 parts per billion. Even small amounts can add up quickly to put you over that amount. You can control some sources of zinc by keeping materials inside a building or undercover, coating galvanized surfaces, keeping dumpsters closed, and sweeping paved surfaces regularly. But sometimes you need to look further. Associated Petroleum Products in Tacoma, Washington, thought they had their zinc pollution under control. They practiced diligent source control and even had a treatment system installed. But in 2013, their zinc sample numbers began to creep up.
The first thing we did for source tracing was to sample from some downspouts that collects all the roof water. What I found in that is that the levels of zinc in the water were about at or just under our limits for zinc, which was kind of surprising considering most of the equipment had been checked on the roof and painted for galvanized surfaces. I think too that a lot of our issues with zinc very well have to do with the area that we're in, and things that get blown in from other properties land on our roof, collect in our rainwater, and then go down as part of our discharge off our property. Next, I took a look at the different catch basins around the property. I kind of started at the outside and kind of worked my way towards the treatment system. I tested a catch basin in the front part of our yard where it's near an area where our trucks called tank wagons park. When they come back into the yard after their shift, they have to make pretty tight turns to back into their parking spaces. So I figured that this was probably a tire dust, high percentage tire dust area. So I took some samples out of a catch basin there and found that yes, it was a little bit high. It wasn't off the charts high, but yes, it was high. And even though we are doing sweeping every 2 weeks, I was still seeing that there probably was an accumulation of zinc in these cracks in this asphalt. I took a look at a particular catch basin in the back corner of the property, which happens to sit directly underneath the Puyallup River Bridge, and thought that that could be a culprit for some of the zinc issues that we see here too. So I sampled that catch basin, and sure enough, it was extremely high. So after doing testing of different catch basins and kind of working my way towards the system, I looked at the treatment system itself. I decided to do some inline sampling and found that the zinc levels were different in the different areas of the system, even after areas that should have been treating for zinc. So from the inline sampling and the different things I found, we upped the maintenance schedule. When every time we do a clean out of this, we seem to see those zinc levels go back down. So we definitely kicked up that schedule and now find ourselves doing it quarterly, cleaning out the entire system, which is a bit of an expense, but I feel it's completely worth it to ensure that we have the zinc levels where we want them to be.
While Associated Petroleum Products worked to identify their zinc sources, the Port of Seattle tackled pollution of their own. This time, the culprit was copper. At a regulated level of 14 parts per billion in western Washington and 32 parts per billion in eastern Washington, it's important to identify and reduce or remove, if possible, all sources. Vehicle brake pads, pesticides, marine anti-fouling paint, wood preservatives, copper piping, architectural components, air emissions, and roadway runoff are all sources of copper at industrial sites. Copper piping from sanitary sewer cross-connections can also be a source. Even at extremely low levels, copper can affect fish and other aquatic life. The Port of Seattle was having an issue with copper levels at their seaport maintenance facility, By doing extensive source control and tracking, they found that an average of 300 parts per billion copper was being deposited onto their property from the Alaska Way Viaduct. They suspected that their proximity to this major freeway was a source, so they built the Guzzler to find out.
We asked our maintenance folks to build what we call an innovative sampling structure called the Guzzler. And it's simply a roof with a trough attached to it, and that allows the water to drain off the roof, collect in a trough, and then hang the sampler at the end. And we actually hung the Guzzler up next to the viaduct itself and discovered that we had about 300 parts per billion of copper coming from the traffic that goes over the viaduct.
Even though the copper pollution isn't caused by the Port of Seattle, they still have to account for it on their property. Aggressive source control, such as frequent sweeping, keeping equipment under cover, and oyster shells in their catch basins for copper treatment, keep them in compliance. Although it's not invisible, turbidity or cloudiness of the water is also a concern. Turbidity is caused by sediment or dirt in the water. Heavy metals such as zinc and copper can enter stormwater by hitching a ride on the sediment and flow unseen into stormwater discharges. Turbidity is measured in nephelometric units, or NTUs. This is what 0, 25, 50, and 100 NTUs looks like in water. As you can see, it's hard to tell the difference. And don't forget, in Washington State, the benchmark is 25 NTUs. Sediment sources include tracking in from vehicles, erosion of soils from landscaping and construction activities, unpaved areas, and dust blown in from off-site. Turbidity can be prevented by frequent sweeping of paved areas, keeping bare soils and landscaped areas mulched or covered, and practicing proper erosion and sediment control of construction areas. Removing sediment from aging stormwater pipes in the city of Tacoma reduced the sources of pollution flowing into the Foss Waterway. The Foss has been a working waterway since the 1860s. 120 years of heavy industrial and commercial uses in and around the water led to its contamination by a variety of pollutants.
In 1985, Foss Waterway was declared a Superfund site because of contaminated sediments. So Tacoma and its partners decided to clean up the waterway, and they invested $105 million to remediate the sediments within the waterway. We started a stormwater monitoring and source tracing program, and we've been monitoring the storm drains, both water quality and sediment. And we found that there were pollutants coming into the waterway still. And what we found is that we had these sediment traps that were located throughout the city, and these sediment traps showed that there were still some pollutants associated with sediment. So in order to remove these legacy pollutants that we think were getting resuspended and could possibly discharge back into our clean waterway, we wanted to make sure that we took care of those.
To protect the investment made to clean up the waterway, the City of Tacoma began an enhanced maintenance program. They enlisted their expert staff to focus on the Foss drainage area and began to thoroughly clean the stormwater infrastructure, some of which was 50 to 100 years old and had never been cleaned.
We knew we wanted to prevent any future loading into the Foss. So during the cleaning operation, the first thing we do is we want to block the line. So we have an inflatable balloon type structure that actually inflates inside the pipe and prevents any material or water moving down the line. The next step is we set up one of our Vector trucks, which is just like an oversized shop vac, essentially, is what you're really, if you're trying to visualize what it actually is. Once we have the line corked off, we set our Vector truck on that location. We actually use a jetter hose on the end of a cleaning head, and it actually uses high pressure water and brings the material down to a central location where that oversized shop vac actually is able to pick the material up out of the line. We take that material back down to our decant facility, which is where we allow the water to settle out a little bit further from the material so that we're actually just down to sediments. That material is then rolled in with some of our other street collected sediments and things. And with that, we were able to take the disposed waste to an approved disposal facility.
Whether you're just starting your stormwater management program or you've been at it for years, source tracing and evaluation can keep you in compliance and help you find and remove those invisible pollutants at your facility.